All right, ladies and gentlemen, how we all doing today? Good. I'm glad to hear it. So what we're going to be doing today is we're going to be talking about doing two-step stoichiometry. So what we've been doing in the past couple days, or at least yesterday, we've been doing two-step stoichiometry, but before that we were doing one-step stoichiometry. So we're going from one unit to another. But if you guys remember back when we did conversions of just basic metric units, way back when we did centimeters and meters and feet and lardos and bips and all those other things, we have more than one step. We have 2 steps, 3 steps, 4 steps. Well, we're going to be doing stuff similar to that today, and that's what we're going to start working on the rest of this unit. When we do this, we are going to be going through, and I'm going to show you step by step what you need to be doing. If you ever have questions, though, please send me messages on Remind, email, Canvas. If you want to Zoom chat with me individually, that's perfect. If you want to come into our Zoom chats that are scheduled, that's awesome. Whatever you need to do, just so you have a better understanding of what's going on for when we do end up taking another summative on 2-step and 3-step stoichiometry in the future, all right? So when we're doing our 2-step stoichiometry, there's a bunch of stuff we need to do. But if we take a look at what it says in this top part of the worksheet, it says that the worksheet's been combined, so there's no separation. You're just doing the entire thing now. There's no, oh, we're going to do this part, and then this part, and then this part, and you'll end up with the answer. No, you're just doing it all at once now. So if you don't want to do it all at once, there is that option of doing it as broken up questions, just like yesterday. But in the future, so on the formative we're going to take in a couple days or tomorrow, there is going to be more information that you need, and so you're going to need to make sure that you know how to do it without doing the step-by-step, or at least that you know how to break it out without me giving you those questions, okay? The next thing that we want to talk about is before we do every problem, we always want to balance those equations just so we make sure that we have all the right information. And then balancing the equation is something we've been doing for a long time now. So I expect that you should be able to do it. But if we don't remember how, we just got to make our T-table just like always. We're going to write our elements down. So we have aluminum and we have oxygen on both sides. Only 2 of them, making it real easy for you, or at least somewhat easy for you. And if we take a look, how many aluminums do you have on your reactant side, your left side? Perfect. We have 1 aluminum on our reactant side. And how many oxygens are on our reactant side? 2. Perfect. You guys are crushing it here. Now, if we look at our product side, how many aluminums are there? There are 2. Perfect. And how many oxygens are there? There are 3. You guys are crushing it. Awesome. So now if we take a look at our aluminums, are they balanced right now? No, they are not balanced. So what that means is we have to balance them. How do we balance these aluminums? We're going to multiply our reactant side by 2. You guys are crushing it. Woo! So if we multiply it by 2, where does this 2 right here go? It goes up in the top right here. Perfect. That 2 goes right there in front of our aluminum. Now, our aluminums are balanced. Our oxygen's balanced. No, they're not balanced. And if we take a look, if we're thinking about our oxygens, what's the first number that both 2 and 3 go into at the same time? They're both going to go into 6. Perfect. And the way to do that is to multiply this side by 3 to give us 6. We're going to multiply this side by 2 to give us 6. Man, amazing. So we take this 3 right here, and we're going to put it in front of our oxygen. And we're going to take this 2 right here, and we're going to put it in front of our aluminum oxide. Now that we've done that, we can double check to make sure everything works. Our 2 goes into just this aluminum right here. Our 3 goes into just the oxygen right here. This 2 goes into aluminum and oxygen. Uh-oh. We didn't put the 2 times here. So we have a total of 4 aluminums. Our aluminums don't match anymore. So what we need to do is we need to go back and we need to go and look at our aluminums again. And we need to take another times 2 to make this a total of 4. But we multiplied it times 2 again. So both of these 2's right now have to be in front of our coefficient. So I'm just going to erase it right here just because I have that ability. But what is 2 times 2? Perfect, 4. So we're going to put a 4 in front of our aluminum. Man, I can't write today. There we go. We're going to put a 4 right there, and now we have a balanced equation because our aluminums match and our oxygens match. So now that we have both of those, what we're going to do is we're going to go back into the problem, and we're going to take a look at the question. It says, how many grams of aluminum oxide will be produced when you react 3.84 moles of aluminum with excess oxygen? So what that means is I have 3.84 moles of aluminum. I just have enough oxygen to make that happen, and I want to figure out how many grams of aluminum oxide I'm going to make when I have that much aluminum reacting. Let's set up our chart over here just so we can see what we have to do. All right, so we're starting with moles of aluminum, and we're trying to get to, oh, not moles, grams of aluminum oxide. All right, so we're going from moles to grams right here. All right, so we're going from moles to grams right here, and can we do that? Are we able to go from moles of one thing to grams of a different element or compound? No, we actually can't do this. So this one doesn't actually work out for us going this way. So what we have to do is we have to take steps in order to find this answer. So if we're going from moles of aluminum to grams of aluminum oxide, we can't do that because moles of one compound and grams of another don't work. But I can convert my moles of aluminum to what other things? There's 2 options. I can convert it to grams of aluminum, but I can convert it to grams of aluminum. Is that going to help us? It's not, and it's not going to help us because the grams of aluminum are going to stay grams of aluminum. We can't go from grams of one compound to grams of another. It just doesn't work. So we have to do something else. We're going to go from moles of aluminum to moles of something else. And we can go to moles of what element or compound do you think we want to go to? We want to go to moles of aluminum oxide. So what we're going to do is we're going to convert to moles of aluminum oxide. And the purpose of that is because once we get to moles of aluminum oxide, we can then convert moles of one compound to grams of that exact same compound. So they're the same compound, they're convertible. They're not, we can't do it. So in order to go from moles of one compound to moles of another compound, we have to use what? Perfect, we're going to use our molar mass. So we're going to use, or sorry, not our molar mass. Man, tricking me, guys, come on. We're going to use the mole ratio. And we're going to use the mole ratio to convert, and where do we find our mole ratio again? That's right, we're going to find our mole ratio in our balanced equation. Now, if we want to go from moles of aluminum oxide to grams of aluminum oxide, what are we going to have to use? Is this possible? Can we do this? Yes, we can do this. And we're going to use what? Perfect, the molar mass here. This time we are going to use the molar mass. So we're going to use the molar mass of what element or compound? We're going to use the molar mass of aluminum oxide because our moles of aluminum oxide, we want to get to grams of aluminum oxide. The only element or compound we're going to use is that aluminum oxide. Now, on this side, what I'm going to do is I'm going to write out my molar ratio, and my molar mass. Mole ratio. And we said we're going to find that mole ratio where? Perfect. We're going to find it in the balanced equation. So we're finding our mole ratio in our balanced equation. So if we take a look at our balanced equation, where do we look to find those number of moles that we're going to use in our mole ratio? Amazing. So we're going to look at our coefficients. So the 4 for aluminum, and what number are we going to use for our aluminum oxide? we're going to use our 2 for our aluminum oxide. So what that really means is that for every 4 moles of aluminum that we react, if we use enough oxygen to make this reaction happen fully, we're going to make 2 moles of aluminum oxide, right? So for every 4 moles of aluminum, we're going to make 2 moles of aluminum oxide. This is, if we remember the word, is a conversion factor. I'm going to write that right here. That's a conversion factor that we're going to use in order to find our number of grams of aluminum oxide. Now our next one that we needed to figure out was the molar mass. And we said we needed the molar mass of what element or compound? Perfect. We need the molar mass of aluminum oxide. So we need to find the molar mass of aluminum and the molar mass of oxygen. So what we're going to do is we are going to take our handy dandy periodic table. Oh man, disappearing here. We're going to take our periodic table. We're going to find aluminum, and we'll find out that aluminum's molar mass is 26.98. And we're going to find oxygen, and we're going to find out the molar mass of oxygen is 16. Now, if we look at aluminum oxide, we can just take a look right here. Aluminum oxide has how many aluminums? We has 2, so we're going to multiply our aluminums by 2 to have a total of 26.98 times 2. If we take our calculators and we do that value, we are going to get 53.96. And how many oxygens are there in this aluminum oxide? Perfect, there are 3 of them. So we're going to multiply our 16 times 3, and if we do 16 times 3 in our calculators, we are going to get 48. So we're going to get 48 right here. So then we're going to add these 2 values together, and when we add these 2 values together, we get an answer of 101.96. And what are my units here? Perfect, they're the grams per mole of aluminum oxide. Don't forget the units need to include that element or compound, especially now that we have 2 different elements or compounds that we're going to have to use. We got to be very specific as to which element or compound we're talking about each time we talk about moles or grams, all right? We can't just willy-nilly just throw them in because we're going to interchange them so much. Now our last thing we're going to do is we're going to write out the conversion factor for it. The conversion factor version. Okay, so in order to write out our conversion factor, we need to set it as an equal sign, which means that we need to break this apart. And if we remember to break it apart, it's going to be 101.96 grams of aluminum oxide is going to equal, how many moles does this equal? Perfect, it equals 1 mole of aluminum oxide. All right, so now we have all that information. We're going to go back and we're going to look at our setup real quick. So then we're going to set up our railroad tracks. And to do that, we have to take a look at how many things we have. So remember that when we were doing our railroad tracks for our conversions, when we did it way back in the very beginning, we did 1 railroad track for every step we had to take. So if we take a look at the number of steps we're going to take, we have 1, 2, 3 steps here. We have 3 steps in order to get from our start to our finish. So that means we need 3 railroad tracks in our stoichiometry problem, in our conversion problem. So what we're going to do is we're going to set up our railroad tracks. Whoops. So we have 3 spots. We have 1, 2, 3 sections. What is going to go in section number 1? That's right. We are going to put our given right here. So our given, if we take a look back at our problem, is 3.84 moles of aluminum. So we're going to put 3.84 moles of aluminum right here. Now remember that these moles of aluminum that we have right here, we want those to cancel. So that means we're going to put them on the bottom right here. If we want them to cancel, we have to put moles of aluminum on the bottom side so they cross out. If we go over here to our, if we go over here to our little table, to go from step 1 to step 2, we need to use what? We're going to use our mole ratio because we're going from moles of aluminum to moles of aluminum oxide. So we're going to find our mole ratio, and we're going to find the moles of aluminum right here. And this is what we're going to put in the bottom column right here. So the 4 moles of aluminum goes right there. That way our moles of aluminum, they're getting canceled. They get canceled right here. And that means what goes on the top? The rest of that mole ratio. So our 2 moles of aluminum oxide goes up top. So our 2 moles of aluminum oxide goes on the top. Now that we've done that, we're not done because we want to get to grams of aluminum oxide, and we're in moles of aluminum oxide. So we're going to take these units right here of moles of aluminum oxide. We want them to cancel with something. So we have to find something to cancel these moles with. So if we look back at our handy dandy little cheat sheet way up here, we're trying to go in step 2, we're trying to go from moles of aluminum oxide to step 3, which is grams of aluminum oxide using the molar mass. So now if we take a look at our molar mass, we're going to take our moles of aluminum oxide, and those are what we're going to use to convert on the bottom. Because remember, we want our units from up top to cancel out with the bottom. So that means the 1 mole of aluminum oxide goes here. And that means that what goes on top is going to be the rest of our mole ratio, our molar mass. So it's going to be the 101.96 grams of aluminum oxide. Now that we have all of our units and that these units have all canceled out, what we can do now is we can solve our problem. So we are going to take our 3.84 times our 2 times our 101.96. We multiply everything on top together, and we divide it by what's on the bottom. So it's 4 times 1. So if we do that, let's get our calculators out. We do 3.84 times 2 times 101.96, and we get 783.05. And then we're going to divide it by 4 on the bottom. And when we do this math right here, what we're going to get is we're going to get our 195.76, and our units are the only units that didn't get canceled out. So grams of aluminum oxide are going to be our units here. There we go. So that is going to be our final answer just right there. And so if we think back to our original problem, if we start with 3.84 moles of aluminum, we are going to make 195.76 grams of aluminum oxide in this reaction. All right.